Hi everyone, good evening. So we are going to have physics. We're going to look at, we want to start a new topic that is vectors. So we're going to possibly look at an introduction, and then we look at magnitude and direction, and then possibly also look at addition and subtraction if time allows, and everything else allows. So that's basically what we're going to look at this evening. So this is physics. And then we're saying we're having vectors. Now, the first thing that we need to do is to define what vectors are. So what is a vector? So a vector, right, is a quantity with both magnitude, right, and direction. Okay. So a vector is a quantity with both what? Magnitude and direction. So there are these two things that we mentioned that are very cardinal in our discussion of vectors: magnitude and direction. Okay. So given that, we're going to say that given that, um, given that A is a vector, okay, A is a vector as shown in the diagram, okay, below, right? So let's say we have something like this. We have the xy plane, okay, the xy plane, and then we have a vector A, okay, starting from the origin. So this is vector A. Now, what it means is that this vector is going to have what are called components, okay? So the components, these are basically the aspects of this vector in the x-axis and in the y-axis. So this side you have x-axis, this side you have what? Y-axis. So if we draw a perpendicular line from where it's ending, we come down like that, then we're going to have this part. This is the x component, which is ax. Okay, so that is ax, and then if we draw a horizontal line in dotted like that, this is the what? The y component, which is ay. Okay. So the x component is called ax and the y component is called what? Ay. Now this vector is at an angle theta. Okay. It's at an angle theta to the horizontal. Is that all right? So now, let's look at, there are three things that we want to look at as we look at this vector A, okay? There are three things that we're going to look at as we look at the vector A. So the first thing that we're going to look at is the components, okay? It's the components. So components of a vector, okay? Of a vector. So in this case, the vector A, okay? The vector A has its x and y components, okay, x and y components, which are ax and ay respectively, okay, respectively. So meaning that the x component of this vector A is ax and the y component of the vector A is ay, okay. Okay, so I'm trying to mute Chris because Chris, you're making noise. Can you unmute yourself? Can you mute yourself, Chris? Yeah, you can just, so what you can just do is, you just mute yourself, and then whenever you want to say something, and then you can unmute yourself. But there's still some background noise here and there. Yeah. So whenever you want to say something, you can always unmute yourself. So just press on the icon for the microphone. So you can hear some people talking in the background. All right. Chris, I'm waiting for you to mute yourself. Yes, what I'm saying is that even if you're not saying anything, there are people that are there that are making some noise, so we're able to get that noise. You get the point? Yes. So you can just mute yourself, and then whenever you want to say something, you can unmute yourself. You say what you want to say, and then you will still, yeah. Okay. So let's continue. So if you check just down on the screen, there are those icons. There's the icon, the red button, more like to end the call, and then there's also an icon for video, and then there's an icon for a microphone. So you press on the icon for microphone. You've seen the icon for microphone. Yes, that's the one. Just that on it. Yes, we'll continue, but we are not going to be getting what you're saying, but you'll be getting what I'm saying. All right. So let's continue. Um, so I was saying that a vector A has these two components, the x and y component, okay, which are ax and ay respectively. So the ax is the component in the x-axis, and ay is the component in the y-axis. Now, how do we get those? Now, here we're just going to use our concepts on trigonometry, okay? So look at this. Remember, there's this mnemonic that we usually use, which is SOHCAHTOA. Okay, we usually use the mnemonic SOHCAHTOA whenever we're dealing with uh, trigonometry. Okay, so if we consider the y-axis, right? So remember, if we have a rectangle like this, it means that this side is equal to that side, and this is equal to that. Okay, so what it means is that from here to there, all the way to there, it's ay. So meaning that even this side, this side is ay, and then this is what? Ax. Okay. So meaning that ay, if we get this triangle, it means that ay is the opposite, and then ax is what? Is the adjacent. Right? Ay is the adjacent. So now what we want to get? We want to get the y component. Okay. So remember we said that sine theta is equal to opposite divided by hypotenuse. Okay, sine theta is equal to opposite divided by the hypotenuse. Now, in this case, sine theta is this angle here that we have, and then the opposite is ay, okay, which is our y component. So this is ay divided by divided by the hypotenuse, which is what? Which is a. From there to there, that is a, the vector a. Okay. So now what we are looking for is the y component, right? It's the y component. So it means that the y component, we just make ay subject to the formula. We're going to have ay is equal to a sine theta. Okay, so this is the y component, right? So the components under components are going to say that AY is equal to A sine theta. Okay, so that is the Y component. Then let's look at the X component. I'm going to work it out from this side. So the X component, we go to cosine. Okay, so you know that cos theta is equal to adjacent over hypotenuse, right? So now what is the adjacent? If you look at the triangle that we have, we can see that the angle is right here, and then the AX is what is going to be our adjacent. We're going to have cos theta is equal to AX divided by the adjacent, the hypotenuse, which is A. All right. And then we want to get AX, so we make AX subject to the formula. We're going to get what? AX is equal to A cos theta. Okay. So that's what we are going to have. So that is our X component. So the X component, the X component is AX equal to A cos theta. So those are the components that we have. We have two components, AY and AX, the Y component and the X. Right. Now, what else? Remember, this is the adjacent and this is the what? The hypotenuse. Okay. So let's now look at the magnitude of a vector. Magnitude of a vector, right? So I'm going to redraw that diagram. I'll try to draw it somewhere here. So what we have is this. We have the X component here. So this is AX and this is AY, and we have the angle here. Okay. So now let's look at magnitude of a vector. Right. So now magnitude of a vector, here we're just simply going to use the Pythagoras theorem. Okay. Using the Pythagoras theorem. Okay. So I should believe that all of you are familiar with the Pythagoras theorem, isn't it? So this is A, which is the hypotenuse, and then the adjacent is AX, and then we have what? The opposite. Now remember, according to Pythagoras theorem, we say that A, all right, that A squared is equal to AX squared plus AY squared. Now, what we want to get is A, the magnitude of A. So, meaning that we apply square root on both sides. So, we're going to have A, which is the magnitude of that, is going to be root of AX squared plus AY squared. Okay. So, similarly, if it is this particular vector is in 3 dimensions, right? If it's in 3 dimensions, okay, let me write that down. So similarly, if the vector has 3 components, okay, if it has 3 components, which is AX, AY, and AZ, right? If it has 3 components, then its magnitude is going to be equal to the root of AX squared plus AY squared plus AZ squared. Okay, that's what we're going to have, right? And then from there, we now look at, remember in our definition, we said that a vector is a quantity that has both magnitude and what? Direction. Now, we've only looked at the magnitude part. We now need to look at we need to look at what? The direction part. Okay. All right. So we say for a vector, so we first look, we say direction of a vector. Okay. So we say that for a vector with components AX and AY, right? Okay. Its direction is given by we say that theta is equal to tan inverse of AY divided by AX. Now, how have I come up with that? Let's look at this, right? So remember the triangle we had? It was like this, okay? So this was A, and then we had AY here and AX right there, isn't it? So remember we've already used, sine theta, we've used cosine theta, and then now we look at, remember from the SOHCAHTOA, okay? I said we have this mnemonic SOHCAHTOA, okay? We have the mnemonic SOHCAHTOA. So we've already used sine, we've used cosine. Now let's look at tan, isn't it? So it says that tan theta is equal to opposite over adjacent. Okay, so it means that tan theta is going to be equal to our opposite is AY, and then our adjacent is what? AX. Okay, so we want to remain with line, so it means that, we want to remain with theta, so it means that theta is going to be equal to tan inverse of what is on the right hand side, which is AY over AX, and which is what written down right here. Okay, so here basically we're just using our concepts from trigonometry and from what? Pythagoras theorem. Okay, and that is what we have on vectors. We've looked at component of a vector. We've also looked at magnitude of a vector and direction of a vector. Okay, so let's look at an example. Let's look at an example so that we still have what we've done so far. And then from there, we're going to look at unit vectors. All right. We're going to look at unit vectors, and then probably I'll just introduce addition and subtraction of vectors. We'll probably have to do it in a separate video. Okay. So let's say example 1. So example 1, all right. So let's say, given that uh, given that the force F equal to 100 newton is at, let's say, 30 degrees to the horizontal. Okay, to the horizontal. What is its x and y component? Now remember, force is a vector, isn't it? Okay, force is a vector. So what we have is this in this case. So we have the force. Let me try to draw it a bit more realistically. Okay, so this is the force F, which is equal to 100 newtons. Okay, and then it's at what? 30 degrees. Okay, so we want to find its x and y component. So this is Fy, and then this is Fx. Okay, this is Fx because it's force, so we're using F. All right. So it means that, remember we said that F, and we said that Ax, if it were A, we said that Ax is equal to, Ay is equal to A sine theta, right? A is equal to A sine theta. So in this case, we have F, so it means that our Fy is equal to F sine theta, isn't it? F sine theta. So Fy is then going to be equal to F is the force 100 newtons, and then sine theta, which is theta is 30. Okay, so this is going to be equal to what? Sine 30 should be 0.5. So 0.5 multiplied by 100, that is going to be 50 newtons. Okay, that should be 50 newtons. And then we look for Fx, which is equal to F cos theta, right? F cos theta, and then this is going to be equal to 100 multiplied by cos 30. Okay, now for me, I'm not using a calculator. Cos 30 is what? Is root 3 over 2. Okay, cos 30 is root 3 over 2. If you want to use a calculator, you can use a calculator. it's still going to give you the same answer if you express it in decimals. Okay, so but 2 there is 1, 2 there is 50, so this is going to be 50 root 3. Okay, newtons. So that is going to be 50 root 3 newtons. So if you multiply 50 by root of 3, it should be able to give you the exact answer that you are looking for. All right, so that's how you find the components of a vector, right? That's how you find the components of a vector. Let's look at another example. Let's say example 2. Now, in case you have any problem, you can always unmute yourself and then you ask a question if you have any question, right? So that you're not left behind. If anyone has a question, you can always unmute yourself, you ask, and then I'll be able to respond. So if you're not asking, I'm assuming that everything is okay, right? So let's say a vector, let's say that a force has its components fx equal to let's say uh, 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 4, let's say 4 newtons, okay, and Fy equal to 3 newtons. Okay, find the magnitude and direction of the force. Okay, find the magnitude and direction of what? Of the force. That's what we want to get, right? That's what we want to get. So how do we go about it? Remember what we said? We said that for a vector, let's say A, we said that magnitude is equal to the root of ax squared plus ay squared, isn't it? So in this case, we're going to say that F, the magnitude of the force F is going to be equal to the root of what? Fx squared plus Fy squared, okay? Which is simply going to be equal to what? The root of 4 squared plus 3 squared, which is going to be equal to, this is 16 plus 9, which is equal to what? Root of 25. And what is the root of 25? The root of 25 is simply what? 5 newtons, okay? 5 newtons, like that. So that is how we get the magnitude of this force. Now let's go ahead and calculate the direction. Remember, we said that direction is, we say it's equal to tan theta, okay? Then ay over ax, right? So in this case, it's going to be tan inverse, by the way, tan inverse, okay, of Fy over Fx, which is going to be equal to tan inverse of what? 4 divided by, no, that is 3 divided by 4. 3 divided by 4, which is going to give us what? I think let me get my calculator so that I should be able to find that. All right. So we want to get, this is 3 divided by 4, and then we get the tan inverse of that. This is giving us 36.9 degrees. Okay, 36.9 degrees. So that is how you get the magnitude and direction of a vector. This is very, very straightforward, very simple, and it's very easy to deal with. Okay. So let's look at unit vectors, okay, and then we'll look at example 3, and then we'll be done for today. So unit vectors. So we say that a unit vector is a vector whose magnitude is 1 unit. Okay, whose magnitude is 1 unit. Now, conventionally, all right, conventionally, all right, uh, I, J, and K are the unit vectors. Okay, are the unit vectors in the X, Y, and Z axis. Okay, respectively. Now, what we are saying is that if we have three axes, we have the, let's say we have something like this. Let me use green. Let's say if we have the Z axis, okay, we have the Z axis, the Y axis, and the X axis. So these are at 90 degrees to each other. Okay, so this is the Y axis, the Z axis, and the X axis, right? Now, what we have is that if we get a vector that is 1 unit, okay, 1 unit in the y-axis, this is called J, all right? It's called J. And then a vector which is 1 unit pointing in the z-axis, this is called K, all right? It's called K. And then a unit vector, rather a vector which is 1 unit in the x-axis, it's called I. Okay, so that's what we have, right? That's what we have. Okay, those are what are called unit vectors, right? So then we're going to say that then then a vector with with three components ax, ay, and az can be written in terms of its unit vectors as what? Okay, how do we write it in terms of its unit vectors? We say that the vector a is going to be equal to ax I, okay, plus ay j, okay, and then plus azk, okay, azk, and its magnitude is in, how do we get its magnitude? The same way we got it, the same way we calculated the same formula that we gave initially. So we said that the magnitude of A is going to be equal to the root of AX. You just get the coefficients, AX squared plus AY squared plus AZ squared. Okay, plus AZ squared. Right. So at this point now, let's just look at the last example and then we're going to be done for today. All right? We're going to be done for today. So let's look at an example. So what we say, let's say example 3, calculate the magnitude of the vector of the vector A equal to 3I minus 2j plus 7k, okay, plus 7k. So we want to find the magnitude of that, right? So it's very simple. So remember, we said that magnitude of A is equal to root of AX squared plus AY squared plus AZ squared, isn't it? So this is going to be equal to, that's going to give us what? This is going to be equal to AX in this case is the coefficient of I. Remember we said that A is equal to AX I plus AY J plus AZ K. Okay, plus AZ K. So in other words, AX is the coefficient of what? Of I, isn't it? Like that. So that is corresponding with that. This is corresponding with that together with sign, and then this is also corresponding with the 7. Okay, so this is going to be equal to 3 squared plus negative 2 squared plus 7 squared, which is going to be equal to, this is 9 plus 4 plus 49, okay, which is going to give us the root of what? So let's get that. So that is 9 plus 4 plus 49, which is 62. So this is going to be a root of what? A root of 62. Okay. And then if we apply the square root sign on that, we're going to have root 7.874. Okay. This is 7.87. Okay. Units. And then we have gotten the what? The magnitude, all right? We've gotten the magnitude as simple as that. This is very simple work. So today we have looked at what? We've looked at the components of a vector, an introduction first, and then we've looked at components of a vector. We've also looked at what? Magnitude of a vector. We've also looked at direction of a vector. And then lastly, we've looked at what? The unit what? Unit vectors, okay? So this is where we're going to end this lesson for today, and then we're going to continue with addition and subtraction of vectors, and then after that we look at multiplication of vectors, under multiplication of vectors we have what is called a scalar product or dot product, and we also have what is called a vector product, or what is also called the cross product. Okay, so vectors is a very simple subject, or very simple topic, which you're going to enjoy as we proceed. Right. So I'm going to end here, and I'm going to end the video right here.